Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about the voltage multiplier circuit simulation in LTSpice. Okay, we will understand how this circuit works, what is the application of your voltage multiplier, and how you can design the voltage multiplier for your medical devices. For this application, let us say your input voltage is 4000 volt and your input frequency is 40 kilohertz sinusoidal wave you have, and you want to generate 20 kV DC at 0.5 milliampere. So friends, please join the channel membership by clicking on the join button. Okay, you can see here different options like premium membership, LTSpice simulation, and you can also join here the mentorship program. This is very popular program where you will learn all the queries, where you will learn LTSpice simulation, where you will learn hardware design and simulation by clicking on this join button. Let us understand what is the input voltage for this voltage multiplier circuit. So you can see here, this is my input voltage and this is V in. If I right click on this, you can see this V in is 3500 volt, that means 3.5 kV, and at the same time you can see this is the sinusoidal signal with the frequency of 40 kilohertz, right, with the frequency of 40 kilohertz. So this is your input source. Now you can see your output should be 20 kV DC at 0.5 milliamps current. Okay, so as I already told you, this is used in the medical devices to give the high voltage electrical shock to the patient. Okay, but if you are using this circuit, you need to understand the user safety. How will you define the user safety to your patient or to your customer? Okay, so you can see at the input at this point of time V1, you have to give the 4000 volt isolated supply. Okay, this V1 should not directly connect to your power plug. There has to be isolated. Let us say you are using 230 volt at input. From 230 volt input, you are generating 4000 volt as an output by using some, let us say, flyback topology. Okay, flyback topology. And there from 230 volt input to 4000 volt output, you need to use the class B isolation between the primary and secondary. Okay, now you have this 4000 volt at V1, which is completely isolated, and now you are using the voltage multiplier circuit, okay, to multiply this 4000 voltage to 20,000 voltage or 20 kV voltage at the output of 0.5 milliamps. So your current is very less, so that means your output power is 10 kilowatt. Okay, so you are giving the electrical shock to your patient with 20 kilovolt DC with the power of 10 kilowatt. Okay, since as per international standard this current is very low, so it will not harm your patient, right? So in order to achieve this output 20 kV, what I'm doing is I'm using different stages of the voltage multiplier. Okay, you can see C3, then diode D4, then diode D6, C5, D5, D7, and you can see here C3, D4, C4, D6, C5, D5, C6, D7, C7, then D8, C8, and D9 you can see here. And at the output I have one more capacitor, and you can see this is the load R1, which says that This is that here I am drawing only 0.5 milliamps current. Okay, you need to understand one more thing here, guys. This is very important to understand. Like, you have to divide, since your output is 20 kV, you need to understand the diode selection. This is very important to select the diode. Okay, otherwise, since the, let us say, the PIV of your diode is what, it should be 20 kV, you need to understand the diode peak repetitive reverse voltage. For this case I am using 30 kV diode. Okay, so I have modeled this diode as a my diode, and you can see the R on resistance is 10 milliohm, R off resistance is 1 mega ohm, then V forward voltage is 1 volt, and peak repetitive reverse voltage is 30,000 volt. Okay, so this is basically a circuit wherein you are giving your input 4000 volt 40 kilohertz sinusoidal signal, and you are trying to get the 20 kV output at 0.5 milliamps current or 10 kW power, kilowatt power. Okay, now let me run the simulation and let me show you how your input is behaving and how your output looks like. So in order to run the simulation, you have to go this simulate button, then edit simulation command. You have to click on the transient, and the stop time is 300 millisecond, and I will click OK. Then I go here and I'll directly run the simulation. Okay, now let me show you the input signal. Okay, and directly let me show you the output signal. This second signal is output and this is the output, and let me show you the current. Okay, so that you will understand here more. So you will get here three signal. This is the input signal. Okay, so this is the your input signal, you can see. Let me zoom it. Okay, so you can see you have 3500 peak to peak sinusoidal signal with the frequency of 40 kilohertz. Now you want to see your output signal, so double click on it. You can see your output signal has some ripple, so I'll do like this. You can see your output signal is around 19.57 kV, which is very closer to 20 kV. Let me show you the current flowing through it. So if you click on the current, you can see your current flowing through this resistance IR1 is more or less, you can see it's closer to 515 microampere. That means 0.5 milliamps. So your current is 0.5 milliamps. And let me show you the power here. So let me show you the output power for this circuit. And so guys, I hope you have understood how will you design this kind of circuit, how will you generate the high voltage at output for your application. Okay, so if you have any further question, feel free to ask me in comment section. Thanks for watching this video.